Guys, my name is DeLong. Thanks for coming to the lightning talk. I'm a reliability engineer at Nikola Labs. Nikola Labs is a predictive maintenance and IoT sensors company in Westerville, Ohio, for those of you local. And without any further ado, I'll get right into my talk here. All right, so the name of my talk is Serverless is More, the scale and benefits of using AWS Timestream. If you have any questions, feel free to hit me up at the end or in the middle. It's totally fine, whenever. So quick question before we start. Is anybody using serverless in any of their applications out there? Awesome, lots of hands up. That's super cool. So I'll take you on a little journey of where we've been. Call this slide the original solution. It should probably be called like the 2018, 2019 solution. These things change so frequently these days. So here's the situation that we were in. Our company has tons of IoT sensors that are publishing around the clock. And we want to plot that data, analyze it, ingest it, do machine learning on it, all that good stuff. And specifically focus on the very last block of that diagram there, the database storage. That's the only server-based thing in that diagram. Everything else is serverless. And before Timestream, which is kind of my focus of the talk, there were very few options in AWS as far as like a good time series solution. And we wanted to stay flexible. We didn't want to necessarily commit to one schema over another. We also just wanted it to be easy to ingest the data and query it and change the schema. And as many of you know, AWS has a ton of options for databases. There's RDS, Aurora, that's the traditional relational database. There's DynamoDB, that's the NoSQL option. Elasticache, Redis, those are in memory. DocumentDB, that's like compatible with MongoDB. And then just a smattering of other options. There's like Amazon Key Spaces, Neptune, and there's Aurora Serverless, which was in its infancy in 2018, 2019. So basically our options for ingesting that type of data and having that flexibility at scale was, for us, it came down to RDS versus DynamoDB. And Dynamo, while it's truly serverless, it's pretty inflexible to changing query patterns. You kind of have to know in advance, exactly what your access patterns are, which for, when you're trying to get a product off the ground, you may not have that information. So RDS gave us flexibility and speed. And there were some limitations back then with Lambda, cold start times that have been overcome since then. And also there's some clunkiness between how Lambda connected to RDS. Just Lambda, it's coming up, it's ephemeral, it's coming up all the time, quick connections. But in 2019, a beautiful thing happened. They came out with RDS proxy, which was kind of that middle layer that really sealed the deal. We're gonna try RDS. And basically RDS proxy is just offering a pooling of connections for us. So we went down that route. But quickly,
you want to take questions now, or
sure. Yep. Go ahead.
I'm interested in the database part of it. So you said DynamoDB was not flexible. You didn't have any problems with the contention RDS and the throughput and the IOPS?
Yep. So yeah, what you're heading on is basically at scale is where Dynamo really wins. And RDS, it's good at scale, but at some point you're going to hit that limit.
Right.
And that's basically what I'm going to get into here. So in the beginning, when we didn't have as many sensors out in the field, things were going fine. We started to hit some inherent issues of RDS at scale with Lambda, even with the proxy. User activities were causing spikes, many DB reads at once. RDS proxy, even though it's great, at the time it couldn't connect to read replicas. So you're basically just forced to stay connected to one database, like you could in theory, split out connections to read replicas for reads, but not with RDS proxy. Data ingestion spikes also, cause concurrency issues. Doing analytics and machine learning caused issues when we're trying to query out massive amounts of data. And then also RDS uses EBS storage, which is costly in its own right. So the bottom line is that users were experiencing deadlocks, timeouts, storing spikes. It was becoming impossibly slow to do analytics. And ultimately, we decided to part ways with RDS. And AWS came out with a fantastic tool. This was pretty recent, actually, when it became generally available. I believe it was like 2020, Timestream. So yay, Timestream. Timestream is basically AWS's answer to time series databases. I just have some specs here on the next slide and some sort of boilerplate information. So they say trillions of writes per day. So perfect for IoT, DevOps monitoring systems where you're trying to monitor the health of an application, analytics, web traffic. It's built for that. And then also millions of queries per day. So handling that scale for reads. Another really key feature that we loved was that it stores recent data in memory. So if you need the last week or even the last year to be quickly accessible, you could have that stored in memory, and then it'll automatically push everything beyond that time to a historical data store, which is typically magnetic storage. And also the analytics that we were trying to do on all of our IoT data, a lot of those functions were just built in. So you could query like a regression right out of the database. So a regression is machine learning. So you could just do machine learning right there in the query, which was awesome. We didn't have to like extract it out and then do any ML on it. So lots of key benefits there. And so just to wrap up, the moral of the story, basically the solution for scale was just to go full serverless. And AWS new tool Timestream basically gave us flexibility that we loved about RDS and the scale, which we love about Dynamo. It was basically those two things together, the flexibility and scale. So we could sort of define our query patterns after the fact, after we have data in hand. And then it also just scales like crazy. User spikes were gone with millions of queries per day. The data ingestion spikes gone, again, trillions of writes per day. And yeah, the analytics was where we were most awed. Just the ability to scan over like gigs and gigs in a matter of seconds to do like machine learning and other cool things. And even when it came down to cost, we had a cost savings with Timestream versus RDS. So that's a little story of how we went full serverless for the data ingestion model. I'll probably have time for one or two quick questions.
Is Timestream like a standard RDS or a standard relational database table structure in the background of it, or is it what it looks like when you're interacting with it?
Sure. So do you have to define the schema in advance?
Something along those
Yeah.
lines,
No, you don't have to define anything, which
so
is
you can still do like relational joins and stuff. Like
yep.
that?
Yeah,
Okay.
it's pretty cool. You don't have to define any schema in advance. You can just they sort of break it up between measures and dimensions, which is kind of their own nomenclature of how they handle that. But you can ingest any type of JSON-like object, and then there's still the idea of there being tables. So you could join two tables that have like a similar object in it. So yeah, it's pretty cool.
Kind of a combination of Dynamo or Mongo's document-like structure per item versus plus the relational.
Right. Yeah.
Yeah.
Yeah, it's kind of like best of both worlds. Yep.
So what did it look like trying to transform your current data that you had in RDS and getting it into time series?
Yeah, that's a good question. So we didn't have to change too much for all the data moving forward. We did have to do like a backfill of Timestream. We had to essentially query out all of that data from RDS, which was slow and time consuming and took forever, but it was a one-time thing. And RDS actually, Timestream actually has a rule. You can't ingest past past data from a certain point. So there was a limitation there. It's a little bit clunky trying to like transition to Timestream with a bunch of historical data. So if I would make a recommendation to anybody, it'd be to choose Timestream at the start because you'll get all those benefits moving forward. So good question.